All right, so some examples on how to graph the reciprocal functions, cosecant, secant, and tangent. Let's first start out with y equals cosecant x. And remember, this is the reciprocal of the sine, this is reciprocal of cosine, this is reciprocal of tangent. So I use that, I know that information to really set up the graph. All right, let's get a little chart going here. All right, what's the period of the sine function? Period is 2 pi, right? Or 2 pi over 1, the coefficient of that x is 1. What's the amplitude? Coefficient in front there, amplitude is 1. And so we're going to set up our chart. We're going up to 1, down to minus 1. The period is 2 pi. Half of that is pi. Half of that, pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2. All right, so I got my setup for my curve. Do I know what the sine curve looks like? Yeah, I do. Notice I'm just putting it in dashed lines here. And that is because I'm really graphing, the question asked me to graph the cosecant x. So, what do you know about the cosecant and the sine? They're reciprocals of each other. So let's just take some of the values that I know. What's the sine of pi over 2? Well, the sine of pi over 2 is 1. So the cosecant of pi over 2 is the reciprocal of that, 1 over 1. Whoa, that's the same point. Let's do another one. Let's do the sine of, say, pi over 6. Do you know what that one is? Sine of 30, right? Told you always remember that one, 1/2. So what's the cosecant of pi over 6? Reciprocal, 2. Yeah. So if 30 is 1/2, now we're up to 2. All right. If I wanted to do the sine of pi over 4, I can just look that up on my calculator. So let's do that. I'm in radian mode, so I get about 0.7. So what's the reciprocal of pi over 4? Or the reciprocal of 0.7? 1 over 0.7. You know I don't like that value, but about 1.4. So 1.4. All right. And now I have that graph here. What happens at pi? The sine of pi was 0. What's the cosecant of pi? What's the reciprocal of 0? 1 over 0, undefined. It's important to find those undefined parts in the graph. What do you think is going to happen at 2 pi? Undefined again. So you can see my sketch is going down to this point. What do you think happens after this point? So I need to get a value between pi over 2 and pi. So let's make this 2 pi over 4 and make this 4 pi over 4. So something between there, 3 pi over 4. Changing common denominators to get a quick value to do, right? All right, so what's the sine of 3 pi over 4? Sine, let's do it here again. I am so slow with this calculator though. Sine 3 pi divided by 4, 0.7 again. So you see I'm repeating some values here, 0.7, and then I'll probably get a half, so I can take the reciprocals of those. And notice the graph of the function that I was told to graph, I did in the darker one, the other one in a dotted line. Where do you think the reciprocal of this part's going to go? Hope you guessed down here, and it does hit that graph at one point. Okay? Now, if you're doing other functions similar to this, if you had a coefficient 4 in front of this, then the first sine curve would go up to 4, and then you'd have your reciprocal flipping over there. So pay attention to where the period and amplitude are in these because they're important, and I'm going to look at those. I'm also going to want a few specific points that you plot. So when you're doing these reciprocal functions, do the points of the partner function first, and then do the reciprocal of them, and show some work. Okay? So here's the work for the cosecant. The secant function does the same thing. So again, to do the secant function, first of all, I want to look at what does y equal cosine x look like, and then I'll graph y equals secant x. Again, I like you to find some specific values, so we're going to start off with, well, first of all, what does the graph look like? The cosine function goes up to 1, down to -1, period 2 pi again. And let's just do a sketch of that function, okay? First, there's the sketch in a dotted line, all right? Now I'm looking for these curves, so make sure you show them, all right? After that, I know that the secant function is going to be the reciprocal of all those points, so let's plot a few specific points. So let's do the cosine of 0. Let's do the cosine, well, let's put these division points here. So this would be pi, this would be pi over 2, this would be 3 pi over 2, and so let's do cosine pi over 2, cosine pi, and maybe we're going to want to do some values in between. So in fact, let's make room for those. So let's do cosine 0. Let's do cosine pi over 6, cosine pi over 4, and then cosine pi over 2. That'll give us some values to look at, and then we can look at how do they change for the cosecant. So what's the cosine of 0? You can see here it's 1. What's the cosine of pi over 6? And again, you can use your calculator. Okay, so we're going to do the graph of the cotangent x, but remember its partner function is y equal the tangent of x. So I'm going to look at that curve first and do the reciprocals. Again, show your work for one little period, or one section of the period of this function. I need to see some values on your paper for your work, so don't do the whole thing on your calculator. All right, again, let's look at the quick sketch of the tangent curve. Period is what? Hope you remembered that it's pi for the tangent, not 2 pi, okay? In this particular one, the amplitude is 1. It's really hard to distinguish that, but the whole curve ends at pi, so half the curve ends at pi over 2. That's going to be the same for the cotangent curve. So at pi over 2, the tangent of pi over 2 is undefined. So let's write down some values. Tangent, tangent, tangent. I want at least 3. Sometimes 4 is good. At pi over 2, tangent of pi over 2 is undefined, right? So what about the tangent of 0? Tangent of 0 is 0. So what about pi over 4? And what about maybe pi over 6? Let's try those. Tan pi over 4, tan pi over 6. So we need some more values in there. How am I going to get them? Use a calculator. Okay, so you can see I have the values here for some key points. So now I need the reciprocal values. So I need, what's the cotangent of 0? Well, the reciprocal of 0 is undefined. What's the cotangent of pi over 4? Well, the tangent of pi over 4 is 1, so the cotangent is a reciprocal, 1 over 1. The cotangent pi over 6, 0.58, so the reciprocal of 0.58 is about 1.72. Cotangent pi over 3, what's the reciprocal of 1.73? That's about 0.57. And the cotangent of pi over 2, the reciprocal of undefined, is 0. So there you have some values to plot for that graph. Now, again, in a dotted line, the tangent curve is this one and this one. And again, it continues up there if I want, but I'm doing just one period, so we're not going to have that continue there. Let's get rid of that. All right, now, where is the reciprocal? All right, the reciprocal of 0 is undefined, so now I'm going to have an asymptote here. And at 0, I'm going to have a point where it was undefined before. Reciprocal of 1 is still 1 at pi over 4. And you can see if I plot some of those other values, I'm getting that curve there, right? And then the reciprocal down here is going to come down like this. So there you have the cotangent curve. Again, if you have a variation of the cotangent curve where you have a 2 theta there, then you're going to have to make the period even smaller. Just remember what the standard period is on that so that you can do that. Another helpful hint is doing your start point and your end point.